guys, welcome to our YouTube channel Learning by Physics with Team 320. My name is Abhishek Sharma and today's our topic is propagation of nerve impulse. So a wave of electricity activity. The nerve impulse are or action potential are the electrical signals that allow neurons to communicate with each other. These signals travel rapidly along the neuron's axon, a longer slender projection that extends from the cell body. The propagation of nerve impulse is a fascinating process that involves a series of ion movements across the neuronal membrane. So the role of ion channels, the role of ion channels, the neuronal membrane contains a specialized protein called ion channels that regulate the flow of ions, so like such as sodium ion and potassium ions across the membranes. These channels plays a crucial role in generating and propagating the action potential. It steps in action potential propagation. First step is resting membrane potential. At rest, the neuron maintains a negative membrane potential, meaning the inside of the cell is negatively charged compared to the outside. This is due to an uneven distribution of ion across the membrane maintained by the sodium potassium pump. The second one is depolarization. When a stimulus reaches the neuron, it causes a localized depolarization of the membrane. This means membrane potential becomes less negative. If the depolarization reaches a certain threshold, voltage get at sodium channel open, allowing a rapid influx of sodium ions into the cell. This further depolarizes the membrane and inside the cell becomes positively charged. The third one is repolarization. It's after a brief period the sodium channels inactivate and voltage get at potassium channel open. Potassium ions flows out of the cell, repolarizing the membrane and restoring the negative internal charges. The fourth one is hyperpolarization. The potassium channels may remain open for a slightly longer period, causing a brief hyperpolarization where the membrane potential becomes even more negative than the resting potential. The fifth one is refractory period. During this period, it's difficult or impossible to generate another action potential. This ensures that the action potential travels in direction down the axon. Now the propagation along the axon, the depolarization at one point on the axon triggers the opening of voltage gate and sodium channels in the adjacent region, causing a depolarization there. This process continues down the axon like a wave propagating along a rope. Myelin and cell tertiary conduction. Many axons are covered in a fatty substance called myelin, which acts as an insulator. Myelin sheaths are interrupted at regular intervals by gaps called nodes of Ranvier. Action potential jump from one node to next, a process called cell tertiary conduction. This significantly increases the speed of nerve impulse propagation. Now the factors affecting conduction speed. Such several factors influence the speed of nerve impulse propagation. First one is axon diameter. Now the larger diameter axon conduct impulse faster due to lower resistance to ion flow. Second one is myelination. Myelinated axons conduct impulse much faster than unmyelinated axons. Third one is temperature. High temperature increase the speed of ion channels opening and closing, leading to faster conduction. Now the clinical significance is disruptions in nerve impulse propagation can lead to various neurological disorders, including multiple sclerosis. It's the demyelination of axon disrupts nerve impulse conduction, leading to a range of symptoms, including muscle weakness, sensory disturbance, and cognitive impairment. The second one is peripheral neuropathies. Damage to peripheral nerves can impair nerve impulse conduction, causing numbness, tingling, and pain. Research and future directions are like researchers continue to investigate the intricate mechanism of nerve impulse propagation, seeking to understand how this process is regulated and how it can be affected by disease. This acknowledge is crucial for development new treatments for neurological disorders that affect nerve conduction. So thank you guys.